a celestial junkyard, Earth's orbit under siege. Our planet is enveloped by a bustling network of satellites. These technological marvels facilitate global communication, navigation, and weather forecasting. However, this vital infrastructure is increasingly threatened by a growing cloud of space debris. This debris ranges from defunct satellites and spent rocket stages to fragments from collisions and explosions. The sheer volume of these objects poses a significant risk to operational spacecraft. Imagine a highway perpetually congested with abandoned vehicles, scattered parts, and speeding projectiles. Thousands of tons of debris hurtle through space at tremendous speeds, posing a constant threat to active satellites. The accumulation of this debris is a direct consequence of decades of space activity. Even small pieces of debris can inflict significant damage due to their high velocities. A collision with a functioning satellite can cripple or destroy it, disrupting essential services. The increasing density of debris increases the probability of such collisions, creating a dangerous cascade effect. The continued proliferation of debris will make space exploration increasingly hazardous. It is imperative that we address this issue to protect our vital space-based assets and ensure the future of space exploration. Space debris travels at astonishing speeds, often exceeding 17,500 miles per hour. At these velocities, even a small fragment of paint can cause significant damage upon impact. The kinetic energy carried by these objects is immense. The impact can disable or destroy a satellite. Astronauts conducting extravehicular activities, or EVAs, are also at risk. A collision with even a small piece of debris could be fatal. The International Space Station has had to maneuver several times to avoid potential collisions. Smaller pieces of debris are particularly difficult to track. These undetected fragments pose a significant threat to spacecraft. The escalating danger necessitates urgent action to mitigate the risks. The Kessler syndrome describes a catastrophic scenario where collisions between objects create a cascade of further collisions. This chain reaction could generate an exponential increase in the amount of space debris, rendering LEO unusable for generations. Imagine a single collision between two satellites. It creates a cloud of fragments, each posing a threat to other satellites. These fragments then collide with other objects, creating even more debris. The density of debris in certain orbital regions is already reaching critical levels. As the debris density increases, the likelihood of a cascading chain reaction also increases. The Kessler syndrome is not merely a theoretical concept, it's a potential reality that could severely impact our spacefaring capabilities. Section 4. The domino effect consequences of the Kessler syndrome. The Kessler syndrome could have a devastating impact on our modern world. Satellite communications, which underpin global connectivity, would be severely disrupted. This disruption would affect everything from international phone calls to internet access and financial transactions. Weather forecasting relies heavily on satellite data. The loss of these satellites would compromise our ability to predict and prepare for severe weather events. Space exploration would become significantly more challenging and dangerous. The increased debris density would make launching and operating spacecraft in low Earth orbit extremely risky. The economic and societal consequences of the Kessler syndrome would be far-reaching. Section 5. Averting catastrophe, solutions for space debris mitigation. Several promising solutions are being developed to address the growing problem of space debris. One approach involves actively removing existing debris from orbit. This can be accomplished using specialized spacecraft equipped with nets, harpoons, or robotic arms to capture debris and deorbit it. Another strategy focuses on preventing the creation of new debris. This involves designing spacecraft with end-of-life disposal plans. These plans might include controlled re-entry into Earth's atmosphere or maneuvering the spacecraft to a graveyard orbit. International cooperation is crucial for effective space debris mitigation. Establishing common standards and guidelines for space operations can help reduce the generation of new debris. Sharing tracking data and coordinating debris removal efforts are also essential. Section 6. Safeguarding our future in space. Preserving the space environment for future generations is not just a scientific or technological imperative, it's a shared responsibility. The consequences of inaction are too significant to ignore. We must act now to prevent the Kessler syndrome from becoming a reality. The future of space exploration hinges on our ability to manage the debris problem effectively. If we fail to address this issue, we risk jeopardizing our access to space and the invaluable benefits it provides. Protecting space is not just about safeguarding satellites and spacecraft. It's about ensuring the sustainability of human activities in space. The future of space exploration, and indeed our future on Earth, depends on it.